Hello everyone, in this video we're going to talk about how to solve quadratic equations using square roots. And so what this is going to look like is we have a quadratic equation with essentially no bx term. So if we think about what a standard form quadratic equation looks like, we have ax squared plus bx plus c is equal to 0. So with using square roots, we're going to have just the x squared term and then our constant, and we're not going to have that bx term. So basically what we're able to do is just use inverse operations to isolate the x squared term. Then we can take the square root of both sides and arrive at our solutions. So we're going to look at three different examples here where we come out with three different types of solutions. So we start with example number 1. We have 2x squared plus 14 equals 70. And we're going to go ahead and subtract 14 from both sides. So once we do this, that's going to give us 2x squared is equal to 56. And now we can go ahead and divide both sides by 2 to get x squared is equal to 28. And so now here we can take the square root of both sides, and anytime we introduce the square root, we need to say this is equal to positive or negative square root of 28. And now square root of 28 can be simplified because we have a perfect square factor of 4. So we could write this as x is equal to positive or negative 4 times 7, right? And then the square root of 4 is 2. So positive or negative 2 root 7 is how we could write that. So that means we have two real solutions. We have 2 root 7 and we have negative 2 root 7. All right, let's take a look at number 2. We have 4x squared plus 20 equals 16. So let's do the same thing. Let's isolate our variable. So we're going to subtract 20 from both sides. We get 4x squared is equal to negative 4. We divide both sides by 4, and we get x squared is equal to negative 1. Now at this point, we would go ahead and take the square root of both sides, but notice what happens. We're trying to take the square root of a negative here, which is not going to give us a real solution. So in this case, we're just going to be able to stop here and say there are no real solutions, because we can't take the square root of a negative. All right, so we've seen two real solutions, we've seen one real solution. Now let's take a look at number 3. So we have 3/4 times the quantity of x plus 1 squared is equal to 10. So let's go ahead and multiply both sides by 4/3 so we can get rid of this fraction. So I'm going to move this number 3 over just a little bit. And so now let's write multiply by 4/3 here. All right, so that's going to cancel our fraction. So now we have x plus 1 quantity squared is equal to 40 over 3. Okay, so now what we can do is take the square root of both sides. So square root and square root. So now we have x plus 1 is equal to positive or negative, and we have square root of 40 over 3. Now with the square root, we can break that apart between the square root of the top and the square root of the bottom. But first, before we do that, let's subtract 1. So now we have x is equal to negative 1 plus or minus the square root of 40 over 3. Okay, so now let's simplify that radical a little bit. So we have x is equal to negative 1, and let's call this plus or minus square root of 40 over the square root of 3. Okay, now when we have a square root in the denominator, we cannot leave that. So we want to rationalize this denominator by multiplying by root 3 over root 3. So now once we do this, we're going to have x is equal to negative 1 plus or minus. This is going to be the square root of 120, and we just have a denominator of 3 now. Okay, so now since we have 120 in there, we can simplify that. Think about perfect square factor has a perfect square factor of 4, right? So we could write this as x equals negative 1 plus or minus, and this would be 4 times 30 divided by 3. And we can write that now as negative 1 plus or minus 2 root 30, and we can divide that by 3. Okay, so that would be our final answer there. We have negative 1 plus or minus 2 root 30 over 3. And that's how you can solve quadratic equations using square roots.